So, what is infinite bandwidth? This is the model we have already introduced. We already said that this model has infinite bandwidth. What this means that the op-amp passes all signals at any frequency without any attenuation. This is not possible for any real op-amp. A real op-amp attenuates signals above a certain frequency, which is the bandwidth of the op-amp. As a side note, the output impedance of real op-amps varies between a minimum value of 100R and a maximum value of about 20kR. This parameter is not always clearly stated on op-amp datasheets. This is what the transfer function looks like, for the ideal op-amp and a real op-amp. This diagram also shows the transfer function for an ideal op-amp, which is simply a straight, horizontal line. The transfer function for a real op-amp is horizontal up to the bandwidth frequency, which in this case is 35 MHz. After frequency the gain drops off. The drop-off is shown linearly in this graph because it is a logarithmic graph. The bandwidth is 35 MHz. In a later section, we shall show how the finite bandwidth is modeled using either a single or double pole RC circuit inside the ideal op-amp. This is the end of section 8. In the next section we are going to introduce the concept of feedback. Why do we add feedback and what is the benefit of feedback? Finite bandwidth and feedback interact with each other, as we shall see later. So, before we combine the two, we are first going to introduce the concept of feedback.